I don't know what that would taste like exactly. Sometimes it's called the Kentucky banana because they find it in Kentucky and it kind of looks like a banana when it's closed, but it's like fat. Um, Very interesting. Um, Gary, you've had a papa before? I should have asked that question. Has anyone had a papa? It sounds like Gary has. Oh yeah, the papaya. Bleh. Papaya smells weird. It is sometimes like when settlers came here, they thought that it was a papaya, but it's actually not a papaya. It's like its own thing. But I think that might have to do with like its kind of funky name. Kind of sounds like papaya. Um, Zephyr, you've tried a papa before. Does it taste good? Maybe, maybe not. It's all right. Interesting. So, the papa, Kentucky banana, had no flavor. Interesting. Very interesting. So, today I'm popping the attendance into the chat. If you have not taken attendance yet, please do so. Password is animals. Password is animals. Thank you guys for coming in and getting ready. Today we're going to do assignment 9, but before we get there, we're going to talk about college reps because you know I love college and I love having college reps here. So we're going to check in as well. We're going to do my favorite no, talk about assignment 8, which was from Tuesday. I know it was a struggle for some of us. That is totally fine. And then we'll jump into the notes and the assignment. For college rep visit today, like in just a few short hours, Soka University will be here. They are a small college here in California. We talked about them on Thursday, maybe Tuesday. I think we talked about them on Tuesday. They are a small college here in California. So if you want to stay in California, but you want to get out of LA, that might be a cool option for you. Chapman University is coming next Monday. So before I see you again, Chapman University will come. One of my own advisees goes there. She loves it. I asked her what she said the best part was, and she said, I don't know, miss, I haven't gone there yet, but it's pretty cool. So direct quote from my advisee. They're coming on Monday. You can check that out. It'll be in your sign up form. I'm sorry, it'll be in your check-in form. And then next Tuesday, the University of Redlands is coming, also a California school. Sometimes, well, they are awesome. They come every year. So you can check them out as well. Just a reminder that going to a college rep will count for your research portion of your PT for this quarter. We're going to talk about that during week 10. So this is week 7. We're wrapping up week 7. We have 8, 9, and then in week 10, we'll talk about the PT. Talk about the PT. So sweet. We did college rep visits. We're going to talk about my favorite no. My favorite no, just checking in before we get there, the checkpoint from Tuesday was pretty strong. Average of 3.33 was our score. Lots and lots and lots of 4s, right? So over half the class got 4s, which is awesome. Means that our median is 4 out of 4. I'm a big fan of that. This was the one about parallel and perpendicular lines. This was my favorite wrong answer because I think it showed me a lot of information about what we're thinking about perpendicular lines. So the question was, which of the following is the equation of a line perpendicular to the line given by this equation here, y equals negative 3x plus 9, right? So since it's perpendicular, what do we know about the slope? Since it's perpendicular, what do we know about the slope? What do we know? Is it the same or is it different? It's going to cross like an X. Yes, it's perpendicular. So do those have the same slope? Different slopes. Different slopes, right? Same slope would be like this. Different slopes like this. I'm seeing the slope is the opposite. Yes, it's the reciprocal as well. So since this is a negative, we need to have a positive slope. So I'm going to look, I'm going to say this one, B is out because it's negative and that's negative. So B is out. This is negative, it's out, right? So it could be A, it could be C. I'm also seeing Jasmine saying that it's the reciprocal, right? So I'm taking 3 over 1 and I'm flipping it over for the reciprocal to be 1 over 3. So my correct answer was C, as we saw here, 54, 75% of us got that. But a bunch of us chose another answer. That's why I wanted to talk about this one here, right? So the most commonly missed question or missed answer was A. And I think that was just people who changed the -3 into a +3 and changed the +9 into a -9. That's not how it works. You want to take the fraction, the slope, and flip it upside down. Okay. You guys rocked it out though. I did want to talk about assignment 8. Assignment 8 was a little rough, y'all. Not a little rough, very rough for some of us. Our submission rate was about 50%. To put this in perspective, normally 80% of you guys are turning your like assignments in on time. So because there was such a drop off, I really wanted to check in about it. One, I recognize the IXL, right? The IXL was a struggle. And the reason that was a struggle, I'm going to totally own that. Is my bad. I forgot that you had to use fractions, right? So when I taught it to you, I should have used fractions. I should not have switched over to decimals. That was lazy on my behalf. So I apologize. So your assignment 8, I'm going to, I have already adjusted it. If you try something on the IXL, I bet you can get a few points. If you try something, you'll get most of the points for IXL. If you get to 25, only a score of 25. If anyone gets to a score of 25, you'll get the full points for IXL. Some of you guys went to 90, and I so appreciate that. You got super extra credit on that assignment for going to 90 or going to your normal 75. I'm super proud of you. I rewarded you with extra credit. So you can turn in assignment 8 still anytime, which is totally fine. Even if you haven't done the IXL, if you've done part 1 and part 3, I would love for you to turn that in so you can get some credit for it. Thank you to everyone in the chat who's helping Isaiah out with the attendance link. All right. We are going to transition into notes time today. Right? We're going to transition into notes. So you will have your 2 options. You will have live action and you'll have team video. If you're team video, it is uploaded to Canvas already. So you're able and ready to do that. If you are going to be live action, then you can grab a piece of paper. I'm going to transition from my computer to my iPad so I can write along with you. If you printed out the notes, grab them. If you've got a notebook, grab it. If you already wrote down the notes, cool. If you didn't, that's okay too. We'll figure it out. So here we go. I'm going to stop sharing this. I'll pick up my iPad. Can't wait until we are all together. That's not what I want to share. Can't wait till we're all together and we can just go for it. ACC, we are all together today. Thank you for that question in the chat. We are all together today. So you can either watch the video in Canvas or you can take notes with us today. Unable to connect. Come on, you can do it. There we go. All right. Can you give me a thumbs up if you can see my screen? It should be moving. No? Let's see. How about now? Can we see my screen? Yes, thank you, Gary, for that thumbs up. Appreciate you. All right. We are going to start here with some definitions, right? Some definitions. If you got a piece of paper, grab it. We are going to jump in. All right. So, yes, on Tuesday, not yesterday, but the last time we met on Tuesday, we talked about parallel and perpendicular lines. And what we are talking about in that moment, when we're talking about 2 equations, we're talking about a system of equations, right? So a system of equations is any time that we have two or more equations, two or more. Today, we're just going to work with two. We're not going to try to push to more than two, but for today. But you should know that a system can come with more than two equations. So we're going to solve those equations by graphing. There are sort of three situations. Remember that you just can sketch these graphs. They don't need to be perfect, right? So if you're writing on paper, you might draw something like this. Woohoo. This type of graph where they intersect is called an intersecting graph. I know, wow, intersecting, where they intersect. So they intersect at this point, and that point where they intersect is called their solution. You guys have done this before, probably. These are one solution graphs. The point where they intersect is their one solution. So those are intersecting graphs. We also have, we were talking about our parallel lines, right? And when we were talking about our parallel lines never touch each other. And so therefore they never have a solution. They don't have a solution. So we would call these no solution. There's no solution, they never touch. If you're drawing on the side, you might just draw two lines that look like this. All right. So those are parallel lines. They never touch. You can call them parallel. But today we're thinking about the fact that they have no solution. They never touch. And then finally, we have what looks like one graph here, right? It looks like just one line. And that is because the lines are on top of each other. So you might have one line that's like right here. And then you might have another line that's like right here. They're like literally laying on top of each other so closely. They're like such the exact same line that we can't even tell that there are two of them. And these have infinite solutions. And the reason they have infinite solutions is because if a solution is anywhere where they touch, these touch at many, many, many points. There's a solution here, 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 right? Forever and ever and ever in both directions, right? As small as you can get, as big as you can get, infinite solutions. So we have infinite solutions. If you're drawing on your own, you can just draw literally one line. You could maybe show that there's a second line by sort of tracing over it. That might be a good idea. So those are infinite solutions. These are our definitions today. Have we heard these definitions before? We've heard these words. Some of us sort of remember these words, maybe from Algebra 1. Cool. All right, so these are our definitions. We are going to start by graphing. There are 5 levels, okay? I know in the IXL that one of the things that tripped us up was that like when the IXL gets harder, sometimes you're like, oh no, Miss Mac didn't teach me this, right? So here's what I've done today. There are 3 levels that everyone is going to do. 1, 2, and 3, everyone will do it. The 4th level is just for honors because it's the problems that come up between 75 and 90, right? It's the hardest level one. And then there's one more for ACC, my accelerated students, because there's like one other thing that you guys are working on today. Okay, I believe all of this will be a review from Algebra 1. I don't think we're going to be hitting you with anything like super new, but we'll get into it and make sure that we know how to do each piece. Okay, so everybody's with me for level 1. For level 1, I see 2 equations. Here's my system. I see 2 equations. I see that they're both already in y equals mx plus b. So I'm going to start by graphing them. So I'm going to start with graphing positive 2. Right, so positive 2. If you are graphing on a blank space, that is totally fine. Just go up to 2. And go ahead and put your point here. And then I know that there is an imaginary 1 in front of that x for the slope. And any number by itself is always over 1. So this pattern is up 1, over 1, up 1, over 1, up 1, over 1. So I'm going to go ahead and draw those points on my graph. If you are drawing. You can go up one, over one like this. So you're drawing that line just like this. Just a sketch. Just a sketch. All right. So we are drawing these lines through here. Just like that. Yes, I totally missed my questions in the chat. I will go back to the beginning at the end. Yeah. So Brian and Mia, sorry about that. I went a little too fast. Thanks for letting me know. I'll go back up at the end. Let's jump into this. Let's finish this one first. All right. And then I'm going to go ahead and graph my second one. Can someone either come off mute or in the chat tell me where would I put my y-intercept for this point? Where did I put my y-intercept? Yeah, -2, I think is what Antoine said. You have Elizabeth also in the chat saying -2. For sure, we're going to start at -2. And then what is my slope here? What is my slope?
Rise 2 over 1.
Yeah, rise 2 over 1. Thanks, Moses and Zephyr. So we're going up 2 over 1, up 2 over 1, up 2 over 1, 2 over 1, 2 over 1, like that. And I noticed that this point right here, that point right there is was doubled up on both the orange line and the blue line. So I'm thinking, okay, that's good. I'm going to have my solution there. Right? So my solution, the whole reason that we're graphing these points is to figure out what that solution is. So I would say that the solution, so if you're drawing just on hand, it's going to be a little more challenging here. We draw like this. So our solution right here. Our solution is at that point there. Our solution is at that point. So I'm going to count what that point is. I see that the x is 1, 2, 3, 4. And I see the y is 1, 2, 3, 4, 5, 6. So 4, 6 would be my point. On IXL, you'll be graphing the two lines and it will be like making your graphs perfect because IXL will only let you put them like on the line. So you'll be able to count them yourself. I know it's pretty challenging if you are over here on the blank space, like actually counting like 1, 2, 3, 4 and 1, 2, 3, 4, 5, 6. You would have to be very perfect in order to find this point here. But on IXL, you'll be able to do it. I did not include any handwritten questions today. And the reason is because it's hard to graph if you don't have graph paper. So I'm going to go ahead and clean up my graph just a little bit here. So I should have that point there. Okay. So that is level 1. We are going to try level 2. Am I okay to move forward? Give me a thumbs up. Had enough time to write it down. Cool. All right. So level 2, we'll try this one here. Go ahead and take a second to write down this system, writing down this section here in level 2. All right. So a little bit more challenging to graph if they're not in slope-intercept form. I'm going to start with this first one here. X plus y equals 1. How could I get y by itself here so that this could be an easier graph? What can I do?
Subtract x.
Subtract x, for sure. Subtract x. I'm going to go ahead and subtract x on both sides. Y is equal to, I'm going to put x first because I want it to be in y equals mx plus b. So I want that plus b to be at the end. Right. I have +1 because the 1 was positive, and I have -x because the x was negative. Perfect. All right. Okay, so now it's in y equals mx plus b, so we can graph it. So I have positive 1. That's where I'm starting. And then remember there is a negative 1, so I'm going down 1, over 1, down 1, over 1, over 1, over 1, down 1, over 1, down 1, over 1, et cetera, et cetera, et cetera, all the way backwards as well. So I have my straight line here and the other direction as well. So I see those points there. So that is very similar. We just had to solve for y this time. How do I graph x equals 3? Is there anyone confident about x equals 3 that would like to tell us how to graph this?
Would it go up and down the whole x? Will go up and down the whole x?
Yeah. So we know
For
it's going to go up and down. Where is it going to go up and down, Antoine?
On 3.
On 3, yeah. So this is really saying like on the x-axis at 3, right? So on the x-axis at 3, and then awesome, Antoine knows that it's going to go up and down. Emiliano, I see you in the chat too. Awesome job. All right, so up and down on 3. So then where would my solution be, guys? Looking at my graph, if your graph is not very specific, looking at my graph, what would the solution be?
3, negative 2.
3, negative 2. Absolutely, right here, where those points are coming together. 3, negative 2. Just like that. Perfect. So this has one solution because there is one place where the points are coming together, right here. Perfect. Okay, for my on track and star, 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 we have one more problem. For everybody, we have one more problem, and then we will do the more challenging ones. So what do we notice about level 3? How has this problem got just a little bit harder? How has it gotten just a little bit harder?
There's multiple numbers on the other side of the equal sign.
Yeah, there's multiple numbers on the other side of the equal sign. They both have to be solved, right? So we have this problem here. I'm gonna go ahead and write down x plus 2y equals negative 8, like that. Yes, Emiliano, you should do this one. And then we also have this other problem here, x plus y plus 3 equals 0. So I want to get y by itself for the pink equation. I'm going to do the same thing, subtract 8. I'm sorry, subtract x, not 8, not subtract 8. So you would have 2y equals negative x minus 8, like that. And then I want to get y by itself. So I'm going to go ahead and divide by 2. Notice when I divide by 2 on the other side, I'm going to divide everything by 2, right? What I do on one side, I have to do to the whole other side. So if you do it to one part, you have to do it to all parts. So that's going to cancel on this side. 2 divided by 2 is 1. 1y is equal to, I'm going to remember that there is a 1 right here, an imaginary 1. So that's like negative 1x over 2. So I'm going to write negative 1 over 2x. I can write it like that. That's going to help me because now I have my rise over run. And then 8 divided by 2. What's 8 divided by 2? 4. I'm seeing from a private chat. Awesome. 4. So it'd be minus 4 at the end. Awesome, Amir. Thank you. So we have negative 1/2 x minus 4. If you forgot the negative, make sure that you have it there. That's going to be our first equation. Go ahead. I want you to take 30 seconds to solve this one here. Take 30 seconds to solve that one there if you haven't already. If you've already done that, go ahead and graph them. All right. First things first, what should I move? How should I do this? Plug in -4. Oh, you're graphing. Oh, yeah. Okay, we can do that. Cool. We'll graph -4. I'm going to put in -4. Then what?
You go backwards. Okay, so you start at -4. You go back
Mm-hmm.
one time because it's negative, and then you go up positive two times.
Ooh, first it's rise over run. I like your idea, right? I like your idea of going back and up, right? That is totally fine. We're gonna go back and up, but we're gonna go up actually, right? We're gonna go up one and backwards two. So I like to think about this one. I still like to think in the forward direction, right? So since it is -1, I'm gonna go down one and over two, one, two. See how my line is now going down? So I'm going down one and over two, down one and over two. So I really like that idea, Sebastian, because we also need to go backwards. So we're going to go up one and backwards two, up one and backwards two, up one and backwards two. So it's kind of like a flatter line here for sure. Thank you, Siva. All right, so I've got this line here. And then I'm going to clean up this graph. I don't want that part. Cool. Someone who has the blue line solved, what should I do with that blue line?
Place the point on -3.
Ooh, -3. Did you solve it already, Anton?
Yes.
Oh, so you knew to move over that -3.
Yes.
Okay, so you know we're going to start at -3. Awesome. And then I also need to move the negative x, right? Y equals -x minus 3, right? Awesome, Lillian. Thank you. So now I'm going to go down one, -1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And I see that we've already found the point where they combine. So then I can go ahead and quick sketch. Whoa, that was way off. Quick sketch the rest of that. So my solution, someone talk to me about my solution. What would that solution point be?
-2, comma -5.
-2, comma -5. Absolutely. -2, comma -5. For sure, for sure. Awesome. Okay, this is level 3. That means this is the end of the notes if you are star, 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 or if you're on track regular, right? So if you're regular math, right, or if you're star, 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 you are done with the notes today. If you are honors or accelerated, we're going to do another problem just to do the highest level. Alejandra, isn't it +2? Yes, it is +2. Thank you for correcting me. +2. It is absolutely +2. Thanks for that correction. Yeah, thank you, Alan. Thank you, Alejandra. That is my bad. Just morning negative. Thank you for letting me know. So if you are star, star, star or on track, you're going to get started on the assignment now, which is IXL to start. You just have IXL and a like check-in form today. So those are the two that you have to do. For honors, let's rock this one out. Honors, I'm going to go ahead and have you solve these on your own because I think that you got it. So go ahead and solve this one here and this one here. If you are regular or star, 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 you can jump onto your assignment. Go ahead and solve those. All right. I'm sorry, honors and accelerated. How can I get started with the one that starts with 4y? What do I need to do?
Divide 4 on both sides.
Yeah, divide 4 to both sides. So I'm going to divide 4 everywhere. I'm seeing a question in the chat. Do we simplify the 2 over 4? And yes, we totally do. We're going to have negative 1 over 2 x minus 3 for sure. And then with our red equation here, I want to move that 6 over 6y equals 3x plus 6. And then I'm going to divide by 6 everywhere. Bye, everyone in the chat. Adios, adios. So we have y equals, I'm also going to simplify the 3 over 6 to positive 1/2 plus 1. Positive 1/2 plus 1. So for this one, I'm going to quickly graph it, negative 3. I'm going down 1 over 2, very similar to my last problem. For my red equation, I'm going to start at positive 1. I'm going up 1 over 2. I see that this is going away from the line, so I'm probably not even going to go that direction. I'm just going to go up this way and see, okay, there's my point, right? I'm just really trying to find that point. And then after that, I'm kind of like, the rest of it doesn't matter too much. So I'm going to go ahead and draw this. And my solution, what would my solution be?
Negative 4, comma 1.
Negative 4, comma, what kind of 1?
Negative 1.
Negative 1, perfect, because we went down. So negative 4, negative 1. Negative 4, negative 1. So honors, you will just have like a little bit more math to do. The only like change in this kind of level was that you should simplify the 2 over 4. You technically don't need to simplify the 2 over 4. You could go down to an over 4, but it'll make it a little bit more simple to simplify. Okay. Honors, you guys are ready to jump to your assignment. You'll have the IXL and the checkpoint question. There are 2 questions at the bottom that ask you to apply what you learned on Tuesday. So remember what you learned on Tuesday with parallel and perpendicular, and then apply that to what we're doing today. So they're just 2 sort of challenging problems at the end. If you have any questions on them, please feel free to jump in into office hours today or jump into my text messages, whatever, in order to ask that question if you have it. I think you'll be able to do it. So honors, you're done for the day. Accelerated, we have just one more. I know, one more. Accelerated, the reason that we have one more is because you are also going to work on inequalities today, graphing inequalities. They are exactly the same as how you were doing them before. You're just now going to graph 2 of them. Okay. So I'm going to go ahead and solve this one here. So we have negative 4x plus y is less than negative 4. So I'm moving that positive 4x. So I have y is less than 4x minus 4. Would this be a solid line or a dashed line? Dashed line,
Dashed.
yes, yes, absolutely, thank you. It is a dashed line. Am I going to shade up or shade down?
Down.
I'm going to shade down. Yes, Amy, thank you. I'm going to shade down because it is less than. So I'm going to graph that line. And then I'm going up 4 over 1. I'm drawing dash, 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 dash. I'm going to go ahead and graph, and I'm coloring in down like this. So I'm coloring in this side over here. Get some coloring practice today. Woohoo. All right. And then when you graph your second one, I'm sure some of you guys have already, oh, we don't even have to solve it. So we're going to start at 10. We're going down 2 over 1 for each of these. Is this a solid line or a dashed line?
Dash.
Oh, yeah, it is dashed. Dash, 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 dash. Right, a solid line or a dashed line. It is dashed. And is it, this is less than, so we're shading down. So I'm going to go to a point and shade down, 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 down. That means I'm going to shade this side, just like this. Just like that. So then my solution, so in the past, the solution had been like where the 2 points cross. That's because the only solution can be like where the line crosses the line. Since these are inequalities, we're talking about anywhere where the solution set overlaps, right? So since this whole thing is a solution and this whole thing is a solution, where they overlap, those will be also solutions. So I'm talking in particular about this section of the graph right here, the yellow section, right? That's where the orange and the blue are coming together and overlapping. We call this the solution set. We call this the solution set. So when you are graphing on IXL, when you're shading on IXL, you want to only shade this section here. So something that might help, you might shade like 2 regions to represent 1 and 2 regions to represent 2. And you're like, oh, okay, both of these are here. So the solution set is this one right here. Okay. Are there any questions about graphing inequalities? Are we feeling pretty good about it? Was this feeling good? Geraldine's feeling good. Thanks for your eyes. Sweet. Cool beans. So you guys will, you have 2, let me show you your assignment. For your assignment for accelerated, you'll put your notes here. You're just going to double check that you turned in assignment 8. Many of you guys already did. And then you have an IXL. You have an IXL. This is the one that everyone is doing, which is just like 2 lines put together. And then the second one is your inequalities. You're only going to 75 on the second one. Anything after that is extra credit. So you're not going to the full 9. You don't have to go to the full 90. You can if you want, but you don't have to. Okay. And then your part 3 is just the same, like Google check-in form, just so we can get some solid ACT practice. Any questions for me? Any thoughts? Feeling good? Okay. Thank you guys for hanging out. I'm going to let you go 2 whole minutes early. Please make sure that you turn in your assignment by the end of the day. Adios, guys. Adios, adios. Bye. Joshua, it is okay. Let me send this to you. And then Josh, please make sure that you watch. Please make sure that you watch the notes on Canvas so that you can like see what the notes are for today. Okay. Bye, Jessica. Cool. Thanks, Josh. Okay, Algebra 2, if you have any questions, go ahead and ask them. Otherwise, it is time to go, and I will say adios. I will see you later this afternoon if you have any questions. Bye, guys. Bye, Emiliano. Sam, Brandon, Adrian, Melissa. Time to go. Alan, adios. Bye, guys.